So what is elasticity of demand? Elasticity of demand is a measure of how sensitive demand for a product is based on a change in price. So it's a percent change in demand based on a percent increase in price. And the relationship here is that as price increases, demand decreases. But how sensitive is the product that you're discussing? How sensitive is it to an increase in price? If it's a very small increase in price, does the demand change significantly? If there's a very small change in price, does the demand really not change all that much? So the question becomes then, how do we measure this change, the sensitivity? So the formula we're going to use is the opposite, right, so there's a negative out front here, of x, price x, so price x, times the derivative of the demand function divided by the demand function. This will give us percent increase or decrease in demand divided by the percent increase in price. And like we said, really what we're doing here is we're looking for the percent decrease in demand, right? When prices go up, demand decreases. Okay, so how do we talk about the elasticity and how do we sort of say what's happening? So if we're given a product and our price is X and the demand, the quantity demanded, the demand at price X, and let's say our elasticity is 0.21. What this says is for a 1% increase in price, there is a 0.21% decrease in demand. Okay, so a full 1% increase in price yields only a 0.21% decrease in demand. So I'm not changing my demand all that much by raising my price. So the demand doesn't change. We say in this case, since elasticity is less than 1, that this product at this price is inelastic. At price X. Okay. Now, as the price changes, this may change. It may become elastic at a given price. So what do we mean by inelastic? So we said there's a small change in demand based on that 1% increase in price. Things that generally are inelastic are things that we consider sort of staple items, staple products like bread, milk, steel, gasoline, and those all have a price at which they are inelastic. That a small increase in price isn't going to affect how much milk you're buying, isn't really going to affect how much gas you're buying, isn't really going to affect how much construction companies and builders are buying steel, for that example. On the other hand, if we end up with an elasticity of, let's say, 1.89, this says for a 1% increase in price, there is a 1.89% decrease in demand at that price. And since we're larger than 1, we say that the demand is elastic at price X. So these are more like your luxury items, or let's say one of our products like gasoline. A few years back, gas prices started to go up and up and up, and once we hit about the $4.25 range, the gasoline at that price became elastic. People severely changed their habits. The demand for gas went down drastically. People started carpooling. They started taking public transportation. They started decreasing vacation road trips and things like that, or even going on vacation. So it's not only related to the product, but it's also related to the price of the product. And one product may be elastic at a particular price, but then inelastic at a different price, or vice versa. Okay, and so we're going to take a look at that and take a look at some examples. So this first one is a demand for computer games. Highwire Electronics determines the following demand function for a new game, where Q is the number of games sold per day when the price is X dollars per game. And we have a nice little graph of our function. A, find the elasticity. Find the elasticity when X equals 3. And at X equals 3, will a small increase in price cause total revenue to increase or decrease? So we'll have that conversation as well. Okay, so we have to remind ourselves the formula for elasticity. It is negative, or the opposite of X, times the derivative of the demand function divided by the demand function. So we need the derivative of the demand. So we'll have to do, that's where our calculus is going to come in. So if the demand function is the square root of 200 minus x cubed, or in other words, 200 minus x cubed to the 1/2, the derivative is, by the chain rule, the extended power rule or general power rule, 200 minus x cubed to the negative 1/2 times the derivative of the inside, which is negative 3x squared. So this is negative 3x squared over 2 times the square root of 200 minus x cubed. So if I plug that into my formula for elasticity, this is the opposite of x times negative 3x squared divided by 2 times the square root of 200 minus x cubed, all over the demand function, which is square root of 200 minus x cubed. So when we simplify this, this becomes positive 3x cubed. X times negative 3x squared is 3x cubed, but negative, opposite of a negative is a positive. And then 2 square root 200 minus x cubed goes down into the denominator, so this will be 2 times the square root squared, so 2 times 200 minus x cubed is simplified there with our algebra. So that was part A. Part B, find the elasticity when x equals 3. So part B, elasticity at 3 is 3 times 3 cubed over 2 times 200 minus 3 cubed. So this is 3 times 3 cubed, 27 times 3 is 81, divided by 2 times 200 minus 27, so that's going to be 173. And we can figure out what that is on our calculators. So that comes out to be 0.234 if we round to 3 decimal places. So that is the elasticity. We would say that this is, since it is less than 1, it is inelastic. A 1% increase in price would only cause a 0.234 decrease in demand, so very little change in demand, even though we raised our price by 1%. And so that's how we're going to what we're going to use to answer part C. It says, will a small increase in price cause total revenue to increase or decrease? So this says a small increase in price isn't really going to change demand. So I'm essentially selling about the same number of items but at a higher price. So if I'm selling pretty much the same number of items but I'm charging more, then my revenue will increase. So if the elasticity of demand is inelastic at that price, a small increase in price at that price point, so I could raise it another, let's say 3 cents, right? Because we're at $3. So if it was 303, I really wouldn't see a change in demand, and I'd be making a little bit more money, and therefore my revenue would increase. So we're going to see what this looks like visually. And so this is our revenue function. So what we're seeing here along the x-axis is price, and along the y-axis, the vertical axis, is our total revenue. And we have sketched a typical revenue function. It's not every revenue function, but a good typical revenue function. And we can see that as price increases, my revenue is increasing and my demand is inelastic at this point. Now, there is a point at which we reach elasticity of 1, or what we call unit elasticity. And at that point, our revenue is maximized. We don't want to go any further than that, because if we start raising prices, our revenue is going to decrease, because a small increase in price is actually going to have a significantly larger effect on demand, right? So on the left-hand side of the graph, a small increase in price doesn't really change demand, and therefore I'm increasing my revenue. But once we get down to the other side here, once we get past that point at which we have our unit elasticity, at which we've maximized our revenue, we start seeing a larger and larger decrease in demand, and therefore now a small increase in price causes a large decrease in demand. And even though we're charging more money, we're getting more money per item, the number of items we're selling is significantly affected. And so we're selling many fewer items. Even though we're at a higher price, we're going to decrease our revenue. All right, so in this problem, we're talking about the demand for oil. And the demand is measured in millions of barrels of oil per day and at a price of X dollars per barrel. We're asked to find the elasticity. Find the elasticity at a price of 75, determine if it's elastic or inelastic, and at 100, and at $25, and then at what price is revenue a maximum. So I've got part of the formula here already. I just need to divide by the demand function. So for this is the opposite of x times the derivative, which is going to be 300 minus 6x all over 50,000 plus 300x minus 3x squared. So for part B, we need E at 75, C is going to be E at 100, and D is E at 25. So at this point, this becomes sort of a plug and chug problem. So you're going to go ahead and plug in 75, figure out what your elasticity is, plug in 100, and plug in 25. So go ahead and pause right now and get out your calculator and calculate those up, and then come back and join me and we can compare answers. Okay, so our result, our elasticity of demand at $75 is 0.20, and that is below 1. So that is inelastic. Very little change in demand for a 1% change in price. E at 100 is 0.6. It's still less than 1, so still inelastic. So we're still not seeing a huge change in demand for a small change in price. And E25, I get negative 0.07. This is still considered inelastic. And in this case, we're actually seeing an increase in demand if we're increasing prices at this point. That's what that negative 0.07, that's negative. And it's also, since it's still close to 0, also that is still noting that a very small change in price is a very small change in demand. So part E is what price is revenue a maximum? And we saw in the previous slide that revenue is at a maximum when elasticity equals 1. So when 1 equals negative x times 300 minus 6x all over 50,000 plus 300x minus 3x squared. So this basically means that when negative x times 300 minus 6x equals, that's when a fraction is equal to 1, is when its numerator equals its denominator. And if we distribute over here, we get negative 300x plus 6x squared equals 50,000 plus 300x minus 3x squared. And then if we add 3x squared to both sides, we get 9x squared, subtract 300x minus 600x, and then move the 50,000 over. And we use our quadratic formula, and we work to solve this. It turns out that x is $114 and approximately 98 cents. We also get a negative value, but obviously the price has to be positive. If the price is negative, that means we're paying you to take the oil, which isn't the case. So we get a price of approximately $114.98. That's when revenue is at a maximum.